Hello friends, hope you are doing well in your studies and in your profession, and I wish you all the best with the ongoing Six Sigma journey for your present and future endeavor. I hope the concepts you have studied so far must have broadened your horizon and must be in fact helping you in your day-to-day life as well as the profession, because the concept of Six Sigma is quite universal and the principles and its application can be visualized, can be seen in all the facets domain of personal and professional life. So let us advance in our Six Sigma journey, and to remind you, I would like to say that we have completed define, measure, improve, and now we are discussing various topics with hypothesis testing started in the phase of analyze. So today we will see the concepts of correlation and regression analysis as a part of analyze phase, and this is our lecture 32. So I would just like to start with a funny cartoon that many a times you may like to correlate, say, non-related things, and this is where you really need to appreciate that correlation is not equal to causation. So if you just see this cartoon, it says that there is a growth in sales and there is the growth in Mostrack say length. So Mostrack length and sales, in a way you can correlate that yes, if there is increase in Mostrack length of the manager, then there is an increase in sales, but you cannot really make any meaningful, say, outcome or any meaningful insight through such kind of causation. So correlation is something to be more meaningful about predicting the behavior of two different variables, and there should be some sense when you are evaluating the two different phenomena. So we had, just as a small recap, we had the Minitab application, as I said, which is quite useful for both university student and the managers, practicing manager, and we have demonstrated the application of Minitab for two different cases. One is pooled variance t-test and another was comparison of two population proportions. So this particular lecture will basically focus on correlation analysis and regression analysis, some basics about predicting the value of a dependent variable based on the independent variable. So just see this, and what do you appreciate? I have just borrowed this graph and I am just putting it here. Does it really make sense? The graph says something like this, that there is, say, a phenomena like divorce rate in men, and this correlates with per capita consumption of margarine. So margarine is a kind of butter that you use to flavor your dish, and these two phenomena are captured over a period of time, maybe from 2000 to 2009, and you have these two graphs resulting. So like our Mostrack example, here you can easily say that yes, if the consumption of margarine increases, then divorce rate will increase. So two different phenomena which has no relationship with each other, if you put it on a plot, you may find that there is a relationship. So this is really not worthy of analyzing, because these two phenomena, they cannot have any real relationship with each other, and we will just be manipulating with the, say, information in order to draw some wrong, false conclusions. So here my point is to say that there should be some relevance. Now I want to put some think kind of situation, and the situation is like this. Let us say in India in Jim Corbett National Park, Uttarakhand, the tiger population X is dependent on a deer population Y. Now, in this particular wild setting, deer are found in a very large herds, and the well-being of an entire deer herd is not threatened by tigers. Fine. So, that is something which is in between. In fact, it is thought that tigers keep deer herds strong. So, this is something which is not really say common sense, and there is something interesting to investigate. So, it is believed that tiger keeps the deer herd strong by helping prevent overpopulation. And can the deer population be used to predict the size of the tiger population? So, something is happening in the wild setting, and this is related with the population of the tiger, population of the deer, and presence of one kind of say animal has an impact on the population of the other kind of animal. Now, here you may like to investigate. Can you find an equation for the best fitting line relating X and Y tiger and deer? Can you use this relationship to predict the size of the tiger population when you know the size of the deer population? What fractional part of variability in Y can be associated with the variability in X, and what fraction part of the variability in Y is not associated with the corresponding variability in X? So, you would see that there is a great scope to investigate different kinds of questions, and you may be interested to answer a couple of them as a part of this investigation. So, I am just giving this preliminary example and not going into the data analysis to motivate you that when we talk about some kind of prediction, when we talk about some kind of relationship between two phenomena, typically our correlation and regression analysis, then that can really bring some interesting fruitful insights for the organization, for the business, for the individual. So, what is then correlation and what is then regression? The technical definition, if you see, then correlation is described as the analysis which let us know the association or the absence of the relationship. There could be relationship, there could not be. So, if there is relationship, then what is that relationship between variable X and variable Y? Regression on the other side predicts the value of the dependent variable based on the known value of the independent variable, assuming that the average mathematical relationship between two or more variables is prevailing. So, you have an independent variable. For example, you want to check that you want to check that there are factors which has an impact on the quality defective items produced in a production setup. So, here your number of defective items produced is typically a dependent variable that have the dependence on many other independent factors like training and skill of the worker, the efficiency of the maintenance system, the production system capability, we have seen process capability analysis, moral of the worker, and many other points finally which will result in the number of defectives. So, you may like to investigate that what are the factors that are really contributing towards the number of defective items produced, and you may like to fit the relationship between the dependent variable, that is number of defective, and independent variables like say process capability, worker moral, skill, and other things. So, a correlation analysis basically say used to measure the strength of the association linear relationship between two variables. So, you have correlation analysis and it is only concerned with the strength of the relationship. No causal effect is implied with the correlation, as we had seen in couple of funny examples initially discussed. So, just see that we had discussion on covariance, when we talked about the measures of dispersion, and we had seen that there is a measure like covariance. So, x and y, so how the variable x and y they vary with respect to each other. So, this could be easily determined by having the expression sigma is equal to 1 to n xi minus x bar, yi minus y bar, n minus 1 in the denominator. So, we have the conclusions based on covariance analysis like this, that if my covariance is greater than 0 xy, x and y tend to move in the same direction. If I have less than 0, they will move in the negative direction. So, it will tell me about the direction, nature of relationship, and if it is 0, they are independent, there is no point in investigating the relationship. So, this covariance has some major flaw, and it is not possible to determine the relative strength of the relationship from the size of the covariance. It will only say that whether they are going in the positive direction or they are changing simultaneously in the negative direction, or there is no relationship, they are independent, but it is not possible for me to say that variable x and variable y they are strongly related with each other, weakly related, or say moderately related. So, I cannot comment on the strength of the relationship. So, here obviously I would like to investigate the strength of the relationship also, and for that you have a measure which is called R, coefficient of correlation. So, coefficient of correlation basically uses the value of covariance xy divided by Sx, that is sample standard deviation of variable x, and Sy, sample standard deviation of variable y. So, you can compute the covariance using the formula we have seen. Sx, because I apply the central limit theorem, I will divide it this particular by n minus 1, and you can just plug in the values in this equation, and this will give you the value of R. So, I have the relationship between two variables which is predicted using the R, sometimes also it is called rho. So, you can have for population coefficient of correlation as rho, and maybe for sample you can use it as R. These are the standard nomenclatures. So, you may have the features like this, they are unit free and ranges from -1 to 1, and if it is closer to -1, stronger negative relationship, closer to 1 then it is stronger positive relationship, and if it is 0 then the say weaker linear relationship, or there is no relationship. So, many times I would like to analyze such thing. If you just recall our QFD discussion, we had created the roof matrix, and roof matrix we were trying to correlate the different technical requirements. Now, when I know that there is a relationship, and if I know what is the strength of the relationship, then when I am making the product or the phenomena which is causing a product to be defective, making it defective, then I can appropriately take the action depending upon the strength of the relationship. So, this has lot of value in making the say system sound and robust and taking the appropriate action, understanding by understanding the relationship between two different variables or the phenomena. So, basically this was what we had seen about the correlation analysis. Now, if we see the regression analysis, it is about predicting the value. Then regression analysis is used to predict the value, and typically it explains the impact of change in an independent variable on the dependent variable. So, I gave you the example that your production system, it is producing some number of defective components, and this may be because of many independent factors. So, you would like to predict that what would be the contribution of each independent factor because of their coefficient in causing the number of defective items. Likewise, you can think about the productivity of the system and many other factors which are contributing. For example, state of the art technology, process capability, moral of the worker, training and skills, and many other factors. So, dependent variable is basically the variable we wish to predict or explain. From my example, it is very clear. An independent variable is the variable used to predict or explain the dependent variable. I can take another example. Say you want to predict the price of a house. You want to purchase a house. Now, there are many factors you can think of. One is the square feet, one is the quality of construction, another may be the location, closeness to the hospital, nearness to the airport, and city, locality, many factors that contribute towards the price. So, price of the house here would be the dependent variable which depends on many independent factors contributing finally towards the price of the house. So, likewise you can just appreciate the difference between dependent and independent variable. Now, if I just talk about basics of some simple linear regression model, then there is only one dependent variable independent variable x, and I want to, let us say, predict the relationship between x and y, which is described by a linear function, and changes in y assumed to be related to change in x. So, this is a very simple model I am just trying to explain as a basics, but this can even be extended by including more number of independent variable, as I gave the example for price of the house. So, this is typically, it looks like that you have the yi, which is your dependent variable. You have beta 0, this is the intercept of your regression model. You have beta 1, this is typically the slope of your regression line. You have the xi. So, here the factors, as I said, location, locality, quality of housing, nearness to airport, closeness to hospital. You can put as many xi as they are relevant to the, say, your dependent factor. Here it is yi, and you have something called epsilon I. In the coming lecture we will see that epsilon I is basically the error which has lot of importance in analyzing my quality of my regression model. So, we will see the validity of regression model in the next lecture, but remember that this epsilon I has lot of value, and predicting also the error associated with the regression model can give me lot of insight into the quality of my regression model. So, this is the observed value of x, y for xi. This is the predicted value of y for different xi, and typically you can see that when I see the difference between observed value and the predicted value. So, I have the actual observation, I have the predicted value. When I find the difference epsilon I, just think that you are predicting the demand. Let us say you predicted a demand of 1000 jackets in the month of November, and suppose when actually you are selling or you are checking the actual demand, it is 1200. So, or it is 800, both the way it is true. So, when you take the difference, then this will be the error in predicting, forecasting typically the number of jackets to be produced for a given season, and this is where epsilon I comes in picture. So, the model is very simple and interesting, that linear regression you have estimated or predicted y value, which is yi hat, estimated of the regression intercept, that is beta 0 or b 0. So, please do not get confused, beta 0 and b 0, beta 1 and b 1 I can use interchangeably. You have b 1 and estimate of the regression slope, and this is my value of the x for observation I. So this is my simple basic linear regression model which is used to predict the y value of y based on the given value of xi. Now here you just try to have little understanding on least square method on your own, and least square method basically I would like to apply here to minimize the error component, and you can see here that error component is explained here as yi minus yi hat whole square. So I want to minimize the sum of square of error so that my regression line can have a best fit when I see that it should pass through the scattered plot, it should pass through the data point collected. So I want to minimize, basically my objective is to minimize, and I can just plug in the values. So yi remains yi, and from the previous one yi hat, that is the predicted value, can be written like this: b0 plus b1 xi whole square. So this is my say function which is to be minimized, and if I can minimize my error component, obviously the quality of my regression or best fit regression I can have for the given data set. So here I am just trying to minimize this function, and what I am doing, that you have already studied the calculus, and when you take the differentiation of a particular function, equate it with the 0, and you try to find the value of constants, this process you have already learnt in 12th standard. So when I do it for a function which is to be minimized, then as a result I will get beta 0 hat or b0, which is y bar minus beta 1 hat x, and beta 1 hat or b1, these are the constants of my regression model. So this would be sxy divided by sxx. So now you have sxx, sxy, syy, all these are basically the sum of squares, and I am trying to minimize the sum of square. So you have sxx, which can be easily determined by using this expression sigma I is equal to 1 to n xi square minus sigma I is equal to 1 to n xi whole square divided by n. Similar way sxy and syy you can determine. So we have the basic equations to find the beta 0, beta 1 for my regression model, and for that I also have the sxx, sxy, syy, which is basically the sum of squares. So b0 is typically estimated average value of the y when the value of x is 0, and beta 1 is the estimated change in the average value of y as a result of 1 unit increase in x. So if you increase your x by delta, what is that unit change? Change in slope, and this is typically reflected by my b1 or beta 1. So now I just want to end this session with some think it, and this session basically has provided you some basic idea, created interest in learning the correlation and regression analysis, and some basic idea on what is correlation, what is regression, what we are trying to do in correlation and regression analysis. We will say study some example as well as validation of the regression model in the next lecture, but before we end, just let me try to float couple of think it for your introspection and self revising. So why we perform regression analysis? Similar way you can think why we perform correlation analysis. What is that something which forces us to go for correlation analysis when we can easily find the covariance? What is the difference between regression correlation analysis? So this is what I explained, and you just try to recollect what is the significance of B0 or beta 0 and B1, beta 1, and also how these constants are determined using the least square function. So these are the references you can use to appreciate the concept of correlation and regression analysis, and you can strengthen your understanding. So correlation basically tests if two variables have any relationship. Regression is established to predict the value of independent variable based on the number of say dependent variable based on the number of independent variables that are contributing towards the dependent variable. So regression analysis is frequently used in prediction and forecasting of a variable based on a set of independent variables. So thank you very much for your interest in learning correlation and regression analysis, some basics, concepts, interesting examples, and I hope this would have strengthened your understanding on fundamentals of the correlation and regression that will help you subsequently in the deeper understanding, developing deeper understanding on the model validation, regression model, and that we will do next time. So till that time, please keep revising, think about various examples where you would like to apply the correlation or regression analysis, and just try to justify that to what extent your analysis is really useful to the organization, company, or a function, and what kind of benefit or result it can give for the improvement in the processes or the function to the organization. So once again, I would like to remind you that we are discussing basically the analyze phase of our DMAIC cycle, and as a part of analyze phase we have gone through the detailed discussion on hypothesis testing for one population, for two population, Minitab application, and now we are doing the correlation regression analysis, and we will go further into the details. So please be with me, keep revising, enjoy.